In today's video, we'll be taking a look at another thermal imaging camera, and this time it's the HIKMICRO Pocket 2. I'd like to say a massive thank you to HIKMICRO for sending this over to review. I always want to make it very clear if I'm working with any sort of review sample, just so I'm completely upfront. However, I will be giving my honest opinion and my honest review of this product. And as you can see, unlike the thermal imaging cameras I've looked at before that connect to a smartphone, this one is an all-in-one unit. And not only does that mean you can use it just as a standalone thermal imaging camera, it gives some additional benefits we'll talk about when we take a look at it. So yep, we have the Pocket 2 here, so we'll take a look at it very quickly. The box has some specs. I'm not going to really bother going into that. I'll talk about the specs when I'm actually taking a look at the camera. So we open it up. You can see in here you have the camera in a nice carrying case, which is really nice. Take a look at what else we get in the box. So we've got some accessories in here. So in here you get a USB cable, so it's a USB-C to USB-A cable, and you get a power supply, just a standard 5V 2 amp USB power supply. Nothing fancy at all, but it's nice to get that in the box actually. You know, even my phone didn't come with a charger and it cost a lot more, so it's quite nice to actually get that. We'll take a look at the camera in a minute, but we'll take a look at what other accessories we get, or paperwork. So you get a little bit sort of welcome type thing, some sort of compliance thing. You get a quick start guide, which is just in a lot of different languages, and one other thing you get that is quite useful, and I've not seen with cheaper thermal cameras, is a calibration certificate. And this is quite good. So obviously if you're using this just at home, this isn't that useful. But if you wanted to use this in a more professional setting or a regulated setting, say building thermal performance type stuff, or diagnostics and things like that, you may either want to have it calibrated or be required to have it calibrated, just to prove that it's working within tolerances and the temperature readings coming out of it are accurate and within spec. So it's good it comes one out of the box. Now, depending on your industry and what you're doing, you may need to get it recalibrated periodically. So this might, you might need to get it recalibrated every year or whatever, but it's really good to get that out of the box. So it means you could use this in a professional setting. And that's like I've noticed when looking at this. Obviously, you can buy it on Amazon and stuff, and I'll put links in the description. But this is also sold by a lot of like proper tool distributors and electrical tester distributors, because obviously it's a higher end unit and it's designed for professional settings and comes with things like calibration certificates. So that's all the paperwork you get in the box there. So now let's take a look at the camera itself, which is the more interesting part. So it's really nice it comes with a carrying case, helps you keep things like the cable with it. A little pouch there to keep stuff in. There's the camera itself, and it also comes with a little wrist strap, so you can attach that onto the camera. There's like a little loop on it there, so we'll take a look at that later. But yep, that's the camera there. It's a very nice form factor. It's not tiny by any means, it's relatively thick, but it feels very substantial, and it's got a sort of really good sort of grippy rubber finish on it, so you know that'll protect it, but also mean it's quite hard to drop, so that's pretty good. So yep, we'll clear, and there I've dropped it. So that's it there. So I'll clear all the other parts out of the way, and we'll take a closer look at it. So now here's the camera itself, so we'll take a look at it. So on the front you've got this touchscreen, I think it's 3.5 inches. Down the bottom you can see you've got a tripod mount, so that's really useful. You can mount it on a tripod if you need to do that. Around the side here you've got a USB-C port. Now we'll talk about this later when we connect it to the computer. It is a USB-C port, it works, but I found a couple little weird quirks with it, so we'll take a look at that at the point when I connect it to the computer. We'll talk about that, but it is nice to see a USB-C port and not a micro USB port. It's just a much more durable connector, so that's good. On the other side you've got nothing, and on top you've got two different buttons, which is a power button and a sort of camera shutter button to take photos and start videos. Now taking a look around the back, you can see the lenses. So here you've got the thermal imaging sensor, and this has a resolution of 256 by 192, which sounds low, but that's actually pretty high for a thermal imaging camera. They don't have camera level resolutions. So 256 by 192 is right up there with some of the highest resolution ones, even at much higher price points. But what's really neat with this is, unlike the ones that connect to smartphones, this also has a regular camera next to it. So it's a normal camera capturing visible light. This is something that the sort of smartphone ones don't really have. And even though your phone has a camera, that camera is really far away from the thermal sensor, so it doesn't really work that well. Whereas with this, because you've got the thermal sensor and the visible light camera next to each other, it has a really good fusion mode that lets you kind of combine the thermal image with a regular visible light image, which means that the pictures coming out of this can be a lot clearer and explain a lot more what you're looking at. So we'll try this out because it's really, really useful. And I think that's one of the main reasons for going for a camera like this as an all-in-one form factor, is having this visible light camera and combining the images from this with the thermal images makes for a much better experience. Finally on the back you have a flash. You can use this as just like a torch just to help you see around, but it also means if you are taking those fusion images and using the visible light camera, if you're in a dark spot, this LED light really helps with that, so that's really good. So before we turn it on, there's one more accessory we're going to take a look at, and that's this. So I explicitly requested that they sent this over because it looks really useful and I really want to try this out, and it's a macro lens. So this is an optional extra, it costs about £100, but what this does is let you look at things that are much smaller. So normally thermal cameras, including this one, you kind of have to go from a fair distance, and that's completely fine if you're, say, surveying the performance of a building or something like that. However, another really useful good use case of these is for electronics repair. So if you've got, say, a circuit board that's not working properly or something like that, you can go in and look at the components under a thermal camera, and quite often if there's a component that's failed or shorting out or something like that, it will show up either really hot or it will show up not hot at all when it really should have some level of heat. So that's a really good use case for thermal imaging cameras. But quite often you're dealing with tiny little components, and a regular thermal camera just can't go quite small enough, it can't see the small enough components. So with this macro lens, what you do is it just clips onto the back of the camera, like that, and that will allow you to see things much closer up. And I've tried it out and it works really well, so we'll take a look at it because this makes it so much easier to see really fine details. But yeah, that, obviously bear in mind that is an optional accessory, so if you're buying this for like buildings performance testing, you're not going to need this. But if you're buying this for electronics repair, this is a really worthwhile addition. If you're buying a thermal camera, you may be trying to decide between an all-in-one one like this and one that connects to a smartphone. And in my opinion, they've each got their advantages and disadvantages. So the disadvantage, I would say, of an all-in-one camera like this is obviously it's larger, which isn't really a problem, but is that it does have a built-in battery. And batteries have a finite lifespan. So while HIKMICRO do guarantee the battery in this for 2 years, 5-10 years time, there is always the risk that the battery will degrade and the device will have a lower battery life or eventually fail. Now the battery life on this is really good. I think they rate it up to 4 hours, and I think when I was trying to drain it down at one point to see how long it lasted, I left it on for hours and it got to like 50%. So the battery life is really good. So it's got a lot of way it could deplete and degrade before it would become a problem. But it is just something to bear in mind that these do have batteries that have a finite lifespan. However, with ones that connect to a phone, you've almost got a different thing affecting you, and that is the app support. Because a camera that connects to a phone requires an app. And it just takes the manufacturer to stop supporting that, to go out of business, stop releasing the app's not be updated for the newest operating system on your phone or something like that. And at that point, you might have issues using the camera. So when it comes to longevity, both of them have issues. Just one has a battery that might degrade, the other one might lose app support. So you're kind of similar there. However, it's just something to bear in mind. However, being an all-in-one camera has the added benefit of having that additional visible light camera, which while you do have that on a smartphone, because it's so far away from the USB port on the bottom, you end up with quite a big parallax effect, so it becomes really hard to try and get the images to line up. Whereas on this, because it's all integrated into one unit, it makes it really easy to do that, and we'll take a look at that later. Plus, being an all-in-one device, it makes it easy as a tool. You can easily hand it to different people, you could be a contractor and give it to different employees, and it would be really easy to do that with. Whereas the one that connects to a phone, you need to have the app on the phone, you need to have a compatible phone and all that kind of stuff. Whereas this is just a sort of point and shoot device. It's literally like a point and shoot camera. You take it, you turn it on, you take thermal images, and you're done. And then yes, while this does have an app that we'll take a look at later and some really good Windows software, there's nothing stopping you connecting this to a computer over USB and just pulling the raw JPEG files off of it and putting them into any editing software you want. See, that's kind of really the balance between the two cameras. An all-in-one camera does have the disadvantage of having a built-in battery that can degrade. However, you've got that built-in visible light camera that's really useful, and you don't need to worry about app support. It will just work, and as long as you've got a computer with a USB port, you can get the files off of it. So what I'll now do is turn this on and take a look at it. So I won't go into all the features of it because it's got a lot of features and it would take a long time to go through that, but we'll kind of take a look at the highlights of the most important ones. So turn it on there, wait for it to start up. It starts up pretty quickly. Give it a little second, and there we go, that's it running. So as you can see, that's it on there. Now, it's not going to really show much useful stuff right now because we're kind of, filming a table, but obviously if I put my hand behind it, you'll see my hand lights up and it shows the thermal image, which is really cool. What I would also definitely say is if you get one of these, make sure you update the firmware. When I first got this, it worked absolutely fine, but there was a couple it just felt a little bit sluggish in points and stuff like that. So I updated the firmware and it made a massive difference, and it also gave it quite a few new features. The firmware is really easy to update. There's just a file you can download from the HIKMICRO website. You connect it to a computer over USB, it shows up as a flash drive, you copy the firmware update file onto it, turn it on, and it'll automatically start updating. So definitely make sure you're running the most up-to-date firmware. But yeah, that's it running, so as you can see, it's working there. Put your hand behind it, you'll get an image. And yeah, it's all working absolutely fine. Obviously, if you press the shutter button on top, it'll take an image, and And if you hold the shutter button down, give it a couple of seconds, it'll start recording, so that's now recording video. And we'll take a look at example footage from this later. I've taken some more interesting things than filming a table. But we'll take a very quick run through of the interface on it. So first of all, you've got this sort of swipe down menu you can use. And this is for things like turning on and off the Wi-Fi and Bluetooth, because you can connect it to a phone over Wi-Fi. This is a sort of dark mode versus light mode. This turns the torch on and off, so that's handy if you want to use the torch. And this lets you adjust the screen brightness. So you can turn it all the way up. And it makes it actually really bright, which is good. So you can easily use this in like direct sunlight, which is good. I'll turn it up a bit because I'm under bright studio lights. And as you can see down here, it's showing the storage available. So this has a built-in 16 gigs of eMMC storage. Obviously it's slightly lower formatted capacity, so you're getting about 13 gigs of storage. Now, if you compare that to a modern smartphone, that doesn't sound like much. When you factor in the resolution of the images this is taking, given their thermal images, that will hold an absolute ton of thermal images. So you don't really need SD cards. This will hold plenty of video and photos internally. You basically will never run out of that. So yeah, you've got about 13 gigs of usable space, which is really good to have. There's a battery indicator up there. So yeah, that's sort of that swipe down menu there. Swipe up to get rid of that. There's then a main settings menu here. This lets you go through all different things. I'm not going to go into all of this, but really in here, for example, you can change the temperature range. So you can change it if it's measuring sort of regular temperature stuff or particularly high temperatures. The emissivity, which is basically, it's not really super important if you're just wanting to get a thermal image, but if you're actually caring about the temperature values, you might want to go in here and you can pick kind of the material that you're looking at, because different materials emit temperature differently and it'll kind of affect the reading. So you can do all that in here. So it's got all these kind of settings you'd want here. Connections, this is where it can connect to Wi-Fi and stuff like that. And even with that, it's quite flexible. So there's a mobile app we'll take a look at later. But what you can either do is have this broadcast a Wi-Fi hotspot, connect your phone to that hotspot and use the app. Or you can connect this to a Wi-Fi network, connect your phone to the same Wi-Fi network, and they'll be able to work over the Wi-Fi like that. So it's actually quite flexible. That's what all that is there. Display settings, this just lets you change what things are shown on the screen. Capture settings lets you do you want to capture multiple images? Do you want some sort of timer? What resolution do you want the image from the visible light camera to be? What do you want to prefix a file name with? Are you using macro mode? Save visual image is quite good. So this means if you're taking a thermal image, it'll save a separate file, which is the image from the natural light camera, so you can kind of have that for reference, which is useful. Edit before saving lets you kind of put text and overlays on the image before you save it. That's really it. You've got device settings under there, so that's just things like the firmware and stuff like that, so that's not super important. But what's more useful is this small menu here that is more for actually using the thermal camera. So as you can see, if we're looking at the screen here, you can see there's a few different points bouncing around on it. So you've got a red point, a blue point, and a point in the center of the screen. The red point always shows the hottest thing, the blue point always shows the coldest thing, and the center point stays in the center of the screen. And in the top left, it shows the readings of the temperature from each of those points. So in this menu here, you can really just turn those off. So if you don't want them all on, you can get rid of, for example, the center one, and it takes it off. I don't see why you'd want to do that. I would just always leave them on. Next up, you have the image mode, and this is where it's really useful. So if you set it to thermal, this is a standard thermal image. So all this is showing is a temperature. So if I put my hand in there, sure enough, you'll see my hand. But if I put, say, a box in there, you kind of see a blur of a box. And obviously if I touch the box, you can see where I've touched it, it's heated up. I promise I've got more interesting thermal things to show later. But that's all you can really see. But if you look at the box, it's obviously off camera, but the box has a whole load of additional information on it. But this is the thing with thermal cameras, is all they show is temperature. So this is fine for now because I can still see the box. But there's a lot of times if you're looking at a thermal image, it can be kind of hard to get the context because a lot of things that are the same temperature as each other just don't show up. You can't really see the difference between them. So that's where fusion mode comes in. And that's what's really good with this all-in-one camera versus a smartphone one. Because if you use fusion mode, what it does is it overlays the natural light, the visible light camera alongside the thermal image, which gives a much more accurate much more useful image because you can see the temperature, but you can also see the real life image. Now, two things you'll notice here. First of all, you'll see it'll occasionally pop up saying image calibrating and freeze. This is normal for thermal cameras. Essentially what it does is every so often the camera has to adjust it has to sort of recalibrate itself because the camera itself is changing temperature as it heats up while it's being used. So what it does is it'll pause for a second, make a little click sound and put a shutter in front of the camera, and it uses that to calibrate itself, and then it'll open up again and start working. So if you ever see it freeze up and make a little clicking sound, that's normal. The other thing you'll notice is that the real life image is slightly offset to the thermal image, that's just something that's kind of unavoidable, because if you look here, the thermal camera and then the visible light camera are next to each other, and they're not in the exact same point. However, on this camera, you've actually got this option here, which is the distance. So what you do here is you set the distance you are from the thing you're trying to get the image of. So in this case, it's set to 0.9 meters. I'm much closer. So if I turn this all the way down to, I think, like, say 30 centimeters, you'll now see the images are a lot better lined up. So really, that's what that is. So if you're trying to do a fusion image, all you need to do is come in here and adjust this. It's really not that much hassle. And I suppose it's almost similar to like manually focusing a regular camera. But what's also really good, and we'll take a look at the Windows software later, if you use the desktop software, you can actually come in after the fact and realign these images, which is really useful. So I wouldn't worry too much about doing it at this stage if you're planning on using the Windows software, but it helps you get them better lined up if you just want to send some of the files straight off the camera. Up here is a zoom option. I wouldn't really use this, it's essentially a digital zoom. So you can zoom in, but obviously you're dealing with already a very low resolution in comparison at least to photos sensor, so you're going to lose a lot of information, but it might be useful, I suppose. So yep, that's that image mode. There's a couple other modes. There's picture in picture. Essentially all this does is just shrink the thermal camera down so it's much smaller, and then you get a sort of natural real world image and a much smaller thermal image in the middle. Visual just turns for some reason to a very, very rubbish low quality stills camera, so I don't know why you'd want to do that, but yeah, you can do that just to get a standard image if you wanted. And blending is kind of like Fusion, it's just much more real camera, much less thermal. Fusion kind of sharpens the edges of the real life image, whereas blending kind of just overlays the two. But they're both probably useful, so you can kind of go through them. I generally find Fusion's the best. Next up, you've got palette, so you can pick between these. So you've got white hot that makes the hottest things turn white, black hot which makes the hottest things turn black, iron bow, which is the one I kind of leave it on, that's the default, rainbow. Essentially all these do is just change the sort of the thresholds at which different colours show up and change the colours used. Sometimes it's a bit of just an aesthetic choice, you might prefer certain palettes to others. Other times you might find some are better than others for what you're doing. For example, the ones like rainbow, that has a very bright red image and then white image for like super hot. So it kind of gives you better contrast, whereas iron bow's maybe a bit softer contrast, but a bit nicer to look at. So you can kind of go through these. It really depends on your application. But the final feature here that's really useful is level and span. And this is something that my other thermal camera doesn't have. So normally it's set to auto, and that works fine. So it means if you bring something in, you can see you've got scale on the left there. It adjusts the scale based on what's in the image. So as you can see there, because my hand's been put into the image, the maximum temperature on that scale is 33 or 34 degrees. If I take my hand out of the image, that maximum now drops down so that the maximum is now 19 degrees, which is presumably the hottest thing it is looking at currently. What this means is if I then put my hand into the image, you'll see the rest of the image completely adjusts contrast. So whereas here you can see the box is slightly warmer than the table, if I put my hand in, because my hand is so much hotter than everything else, it kind of removes that contrast between the box and the table just because the difference between my hand and the box is so significant. And this was an issue I had with my other thermal camera because a lot of the time that can be a bit annoying. For example, if you're say doing a building performance survey and you're say trying to take a thermal image of a room, but that room's got like a radiator in it, or even just a lamp in the corner of the room that's hot, what that can do is it can completely throw off the contrast of everything else. So if you're trying to look for a cold spot on the wall, it's really hard to make out because that lamp is just so hot and it's just adjusting the contrast of the image. So with this, you can change it to manual, and this lets you actually adjust the contrast. So that's set to manual there, and now if I bring my hand in, you'll notice that my hand makes no difference to the overall contrast of the image. Now, of course, you can see the contrast is lower, but that's because it's currently a scale from 19.7 degrees to 17.1. But what you can do here is you can come into here, and you can actually adjust the center point of this, which adjusts the higher and lower bounds. So you can adjust this to roughly wherever you get the best contrast in your image. And then, yes, sure, my hand is now off the scale completely white, and you lose that contrast at the super high temperatures and super low temperatures. It'll let you adjust the scale, which is super useful. So that lets you adjust the midpoint, or what you can do is you can fix one of these points, and then when you adjust the midpoint, adjust the temperature, you're now adjusting the bottom one and leaving the top one in place. So it's a little bit fiddly to get the hang of it, with the way you kind of lock these, unlock other ones, and then you adjust them like that. Something's a bit hard to get these buttons working. There you go. But it is super nice to have this feature that lets you manually adjust the scale. So now that scale is set manually there. You see we can kind of get a contrast between the box and the table, but if I bring my hand in, that contrast no longer changes. Whereas if I put that back to manual mode or auto mode, you'll see again if I bring my hand in, oh, let it calibrate. If I bring my hand in, the contrast completely goes. So this is a super useful feature to have. So yeah, that's kind of the main tour of really the features it has there. Of course, you've also got the feature here where you can just go and view files on the camera. It is also really useful. You can create folders on it, so you can actually create a different folder for each job or whatever you're doing and set the setting to define which folder you want to write the files to. So that's really useful because it means you can actually divide your work up into different folders. There's a bunch of images and videos I've already recorded there, so we'll take a look at some of these in a minute. But yeah, that's really a sort of tour of all the functions. So while it's all well and good just showing a thermal camera on a table and showing my hand going in front of it, it's not really that useful. So what I'll now do is I'll go away and I'll put up some example pictures and videos I've taken with it to show some more real world use cases. So now let's take a look at some examples of how you could use this. And in particular, what we'll first of all focus on is testing things like the thermal performance of a building, looking for missing insulation, looking at heating systems and all that sort of stuff. So when I previously did this, it was in winter, so it was a bit easier because it was much colder outside and much warmer inside. So cold spots in the property were a lot more apparent, but we can still find some things. So the first example here around my front door, you can see that down along the bottom of the door and also in the corner of that wall there, it's a lot colder. Now this is much more apparent in winter, but what you can do is you can easily go around a property, look at ceilings, look at corners, look at walls, look at around doors, windows, all that sort of stuff. Look for any cold spots. And if there's any cold spots there, that could potentially indicate lacking insulation. And it's so easy to do. You can also do it the other way around and go outside the property and look at a property from the outside with the heating on inside. And any hot spots on the outside of the property can indicate where heat's coming out. So this can be super easy, a super easy way to look at the thermal performance of a property, identify missing insulation, and it's just super easy to do. Here's another example that's a bit more apparent, where I've got a window that has trickle vents in it, and obviously the trickle vents are open. So as you can see, because the trickle vents are open, they are significantly colder in the surrounding area. So this is the sort of thing you can identify if you're trying to look for cold spots. Obviously here it is an open air vent, so it's very obvious. However, if you saw that and there wasn't an air vent there, you could go, well, maybe there's a leak, there's a bit of insulation or sealant missing, and there's air getting in or something like that, or heat getting out. It's a really, really easy thing to do. So now as an example here, we can see how we can use this to look for heating pipes. So in my bedroom, I have a radiator directly under the window. And in this flat, all the pipes and all the electrical services all go through the ceiling. So there must be a pipe to go from that radiator up into the ceiling. So I knew the pipe would go either side of the window. However, I didn't have any idea where it was. With a thermal camera, it's super easy. All you need to do, turn the heating system on, let it warm up for a while, and look at the walls. And as you can see here, you can see a pipe going up to the right-hand side of the window, and it's not going up the left-hand side, which is super useful to know, because this means if I want to put a picture on that wall, or say put up a new curtain rail or anything like that, I can make sure I avoid that pipe and don't drill or screw into it. Here's another example of the same thing in my living room, where again I've got a pipe coming up from the radiator that goes at a really stupid angle where you would never expect a pipe to be. So this also really makes sure I don't accidentally drill into that pipe because, well, I was going to put a shelf up there and, well, that could have gone wrong. Here we have an example showing hot water running under it. And as you can see, the water showing is hot, and then if I put cold water in, it goes in cold and you can see it actually mixing around. This isn't particularly useful, but it is just quite cool to see. But it does mean if you wanted to measure the temperature of running water, potentially you could use it for that. As you can see there, the water is max at 54 degrees, which is correct. That's what the boiler's set to. So yeah, this is more just cool to look at, but it's quite a cool example. And now here we have an example looking inside an electrical consumer unit. And this is another really good use for these thermal cameras. And that is looking for things like loose connections. So if you've obviously got an electrical connection that's loose or over tightened and it's not making a good connection, it'll heat up. Now obviously ideally you want to go around and actually test everything, but a thermal camera can make it very easy just to quickly open up a panel or consumer unit, make sure you've got some high current loads running, and just take a look. And if there's anything obviously wrong, you'll hopefully see a hotspot and it'll make it very clear. Now obviously I wasn't prepared to start loosening off connections and causing fire risks, but what I did here is I turned on my cooker circuit. So I turned on my oven and hob and boiled a pot of water and basically drew a lot of current from the cooker circuit and left it for a while. And as you can see here, you can see the live and neutral of that circuit have warmed up. Now this isn't remotely to a dangerous level, this is just normal, but as you can see it's made it very clear and I can easily see those wires. And if the slightly heated up wires is this clear under a normal situation, Imagine how obvious it would be if one of those was loose and getting dangerously hot. This example also shows the benefit of having that fusion mode over a camera that doesn't have that, because as you can see here, you can easily see all the circuit breakers, all the screw terminals, and easily identify which wire is going into which breaker. However, if we just look at the thermal image, you can see you lose all of that detail. You can still see the rough idea of what it is, and you can still see a wire there, but you would be hard pressed to try and identify which breaker that wire was going into without sticking something in front of the camera to point at it and looking at what you were pointing at. Whereas with this, you can easily look at that and identify that it is the second breaker from the right. Super easy, so the fusion mode is super useful for this. Now, as a final part of that consumer unit example, what I did was I set the camera up recording and then turned the oven and the hob on and just left it recording while those wires heated up. Obviously it took several minutes, but if we speed that video up, you get this quite cool time lapse where you actually get to watch the wires all heating up, which is quite cool. Now, moving away from things like buildings and looking at things like technology, here we have a laptop. And this can be quite useful if you're, say, reviewing or testing computer equipment like laptops, be able to review the surface temperatures. And it's something you quite often see with like reviews of laptops is looking at, say, how hot the keyboard gets, or even more importantly, how hot the bottom of it gets, because that can really impact comfort when using the device. So with a thermal camera like this, you can easily test that. And with the fusion mode, it makes an image that's a lot easier to show to someone like an average member of the public in a review than a purely thermal image, which would be a bit hard to really make out. And then as a final example, here we have a networking cabinet. And it's super useful to be able to look at this, see all the different devices, see how hot each device is, see if there's anything getting too hot. And this is another example where the fusion mode is extremely good. Here we have the image with the fusion mode, and here we have the purely thermal image. And you can just see that fusion image has so much more information in it, making it so much easier to use in documentation, or to send someone who's not standing in front of the thing and knows exactly what they're looking at. So that was a bunch of examples where it's useful for like building performance and testing like thermal performance of buildings, heating systems, that kind of stuff. But another super good use of thermal cameras is for electronics repair. Because as I mentioned earlier, if you've got something that's faulty, if a component gets too hot, that might indicate a problem, or if a component that should be heating up isn't heating up, that could also indicate a problem. So I'm just going to do the same example as I did in my previous video because it's quite a cool example. I've got an old laptop here that I've taken the bottom off of, and obviously if you look at it under the thermal camera, you can see it's all kind of the same temperature. So what I'll do is I'm going to make sure that it's got the kind of the right fusion alignment, which it does. I'm going to start this recording, and then I'll sort of do a picture-in-picture thing in the video afterwards to make it more useful rather than just me waving this in, hopefully being able to see it. So as you can see there, the laptop is kind of all the same temperature. You'll see some kind of hot parts around here and over here. However, all that is just because they're metal, they're reflecting heat. So they're kind of reflecting heat from like the video lights and stuff like that. Everything is kind of the same temperature. So what we'll now do is we turn the laptop on, you'll see it'll start to heat up. So you see a lot of reflections there. That's just my hand, my arm being reflected off any metal components. So if we turn it on, get my hand out of the way, and you can now straight away see the laptop starting to heat up. So you can see the heatsink over here is heated up on the CPU. See some of the voltage regulators heating up. You see the Wi-Fi card heating up. You can see the SSD heating up. The SSD is now the hottest part in the laptop. So just heard it just start up there. And as you can see, that's it now all warming up. You can see the chips on the RAM are starting to heat up. So obviously it's a fusion image. I need to kind of get the right distance from it. There we go. If we get the right distance, because it's set to 0.3 meters, that now makes the image nice and lined up. So situations like this are where the fusion image is really useful. Because if you flip back to an image without the fusion image, just a standard thermal image, you lose a lot of context as to what you're looking at. And it's fine if you're just looking at it through the camera because you know what you're looking at. But if you were to try and put this into a report or send it to someone, having the fusion image that's overlaying the real world onto the thermal image makes it so much easier to actually see what you're looking at. So yeah, that fusion image is really, really useful in this sort of context. So as you can see there, we can take a look at the laptop, you can see it's heated up a bit more, so the heatsink over the CPUs, I mean, we'll put my finger in, it's really heated up. Interesting, one stick of RAM is hotter than the other one. I don't know why, I don't know if there's different specs of sticks, I think they are, they're definitely not matched. That's kind of interesting. You see the SSD down there, you can see the temperature there. Obviously, if I make it too close, the thermal image and camera image diverge because of the distance set in the fusion setting, so you kind of have to keep the distance consistent. But yeah, it's working really well, and you can see there's a particularly hot spot here, some sort of voltage regulator. It's actually very clearly hot. I think it's the hottest thing in the image. So yeah, it's working super well. Electronics repair is also where the macro mode is extremely useful. So here we've got the circuit board out of a router, and it's falling off the table. So I've powered this up, so obviously it's going to have heated up. And if you look at it just without the macro lens, you do get a reasonably clear image. But if you want to get in really close, you can see that I'm down here in this corner, there's a component that's a bit hot. I mean, it's hot because it's working, there's nothing wrong with this, but if you get close down there, it goes out of focus. You kind of need to sort of stay maybe this sort of distance to really get any sort of usable image. And while that's fine, it gives a kind of a high level look. If you're dealing with these absolutely tiny components, you might just want to get in a little bit closer. So that's where the macro lens comes in. So we stop that recording there. And all we need to do is put the macro lens onto it. So it just hooks over the back, clips on. And there's also a setting in the menu for macro mode that I'll enable. It doesn't really seem to make much difference, but I may as well enable it just for completeness. So now that's the macro mode enabled. So if we start recording again, and now go in, you'll see it's now completely out of focus at a sort of reasonable distance. But if we go in close, you see so much more detail. Now, of course, the downside with the macro lens is that you then don't have the visible light camera. That's obviously covered up by it. So you lose the ability to see what you're seeing with visible light, but you can get so much more detail out of these components. So you can get really close in. So if you're dealing with a tiny little resistor or something, or a tiny little chip like this one here, you can easily get in there and see it at full size. And for example, here or there we've got I think that's the RAM memory package. And if you get in close, you can even see where the die is in the middle of that chip. The rest of the chip's colder, and there's that die right in the middle. So this macro lens is really, really useful. Definitely not the sort of thing that everyone needs, but if you're buying this for doing sort of electronics repair and diagnostics, the macro lens is definitely a worthwhile investment because this is super useful. You can get really right up there and see these tiny little chips, tiny little components. So yeah, definitely a worthwhile add-on, and it's really nice to be able to get that for this. Okay, so next up we'll test the mobile app. So there's different ways you can connect the phone to this over Wi-Fi. As I mentioned earlier, you can either have this broadcast a hotspot that you connect your phone to, which is what I've done here, or you can connect this to a Wi-Fi network, connect your phone to the same Wi-Fi network, and they can talk to each other over that. And this is particularly useful for like remote control. You could have this sitting over on a tripod and view it from your phone elsewhere, that kind of stuff. It also lets you transfer images off, which we'll take a look at. So we've opened the app here. It's got two different options because they also sell thermal cameras that do connect to smartphones, but we have a handheld device, so we click that. It searches for it on the network, finds the device, so we click that, and it comes up. Other good thing worth mentioning with this app is it doesn't make you log in to use it or anything, so you don't have to set up an account to use this app. I hate when you get devices that make you do that. With this one, the app does just work without an account, which is good. So as you can see, there we've got the image from the thermal camera. So this is a live stream. If we pick the camera up and look around, you can see, sure enough, you're getting a live feed from it, which is really good. In terms of using it, you don't really get many more features on the app than you do on the camera. It basically works the same way. So down the bottom, you've got these buttons. So you've got one here that lets you basically turn on and off the different points. So you can turn on the center, maximum, minimum, exact same as on the camera. Here you can change between things like fusion mode, the real camera mode, all that kind of stuff. Again, same as on the camera. This button is different, isn't available on the camera, and it just forces a manual calibration. So where it does that thing where it clicks and calibrates that I mentioned earlier, this just forces the camera to do it. Finally, you get some settings. So in here, you can do things like set the distance, you can change the unit. It's basically the same sort of settings you'd be doing on the camera, just on the app. You can also obviously take photos on the app and video recording, so you can trigger it remotely, which could be quite useful. But I think and then down here in the corner, you finally got the option to change different color schemes as well. So it's really useful to have the app, but you're basically getting the same effect as you'd be getting on the camera itself. You're just getting the camera's interface moved into an app, so you can control it remotely, which is quite useful, and it's nice to have. It's nice that this just isn't purely standalone. You can use it with a phone. But I think the main feature with this is going to be using this to get photos and videos off of the thermal camera and onto your phone directly. So it's easy enough to do. So I'm connected to the camera here. If we go into the bottom left and go back, this shows the gallery. Oh, so go to there. Go to media on the top right. There we go. This shows the gallery. So this is images that are on my device itself that have either been downloaded off the camera or taken by clicking the shutter button inside the app. However, if we go down to the bottom right and go to on-device files, pick handheld device again, it makes you scan for the camera again, pick that, takes a little second to connect. This now lets me browse the images that are on the device itself. So I can easily come into here, pick an image, press download, and that's now downloaded to my phone, which makes it really easy to get files off of this onto a phone so you can send them to people or work with them. The only thing I would mention that just was a little bit hidden, took me a while to find, is that by default, when you download these files, they will download and appear in this section here, the local on-device gallery, but they're not visible in your phone's default gallery app, which is really annoying. So the only way to get them out by default would be to open the file, click the share button in the bottom left, and then share the image. And this was the same complaint I had with my previous thermal camera. However, there's a slightly hidden setting on this that fixes it. So all you need to do is go to Settings, General, and tick this option that says Save Pictures to Phone. This is obviously the Android app, so it may be different on iOS. But on Android, when you tick that box, it pops up the Android permission thing saying, do you want to give the app permission to access your media? You allow that permission, and now whenever you download a photo from the device, it will automatically appear in your normal phone photo gallery. So your thermal images appear in there, and you can do what you want with them. So as long as you enable that feature in there, that works absolutely brilliantly, and you can easily use the app to get images off of the camera. So yeah, the app is really nice to have. It definitely works pretty well, and it's super useful to be able to control this remotely and easily download images from it. So yeah, very happy with the app. So the mobile app's all well and good. However, where this device really excels is it has very powerful desktop Windows software that lets you analyse and adjust the images after the fact and do things like generate reports. It's super powerful. So all you need to do that is connect the camera to the computer with a USB cable and access the images off it. However, as I mentioned earlier, this USB port is the one flaw/quirk I found with this. And what it seems to be is that while it is a USB-C port, it doesn't seem to be fully compliant with the USB-C standard. So I'll need to explain that in a bit more detail. But essentially, with traditional USB-A ports, it was very simple. The port outputted 5 volts all the time, devices took 5 volts, and that worked. However, USB-C supports a lot more power delivery standards. So a USB-C port can output all different voltages from 5 to 20 odd volts. This laptop charges over USB-C, for example, at 20 volts. And the USB-C connector, or the device connected anyway, the USB-C device, needs to tell the charger or the device that's powering it, be it a charger or a computer or whatever, what voltage it wants. I'm not super familiar with the standard. I think it does it just by putting certain resistor values between certain pins on the USB-C connector. And this doesn't seem to do that. So what does this mean? So, if we take the camera, we plug a USB-C to A cable like the one that came in the box. This isn't the one that came in the box, but the one that came in the box works exactly the same. USB-A cable, take it, use a USB-C to USB-A adapter, plug it to a laptop, so I've got the MacBook Pro here just because it's a USB-C device, plug it in, give it a couple of seconds, camera will power up, or it'll show it's charging, and that will now show up on the computer as a USB device. Obviously this is, generally it's Windows only software, but I'm just using the Mac because it's the only USB-C device I've got. This thing doesn't have USB-C. But yep, the camera's powered up and it'll be showing up on the computer. However, if instead of using the USB-A cable with an adapter, I use a USB-C to USB-C cable, plug one end in there, the other end into the device, you'll see nothing will happen. It won't charge and it won't show up on the computer. And of course, when this first happened, I was extremely confused, couldn't figure out what was going on. So I bought this cheap little USB tester, really neat little thing actually, and we can see what happens. So if I take this, plug it into the laptop, and plug in this USB-C to USB-C cable into this power meter, you'll notice it's plugged in, no power coming out. The screen hasn't turned on, this isn't powered up. If we plug in this device, absolutely nothing happens. Screen on this doesn't come on, this doesn't charge, no power is coming out the USB port. Now on the other hand, if we disconnect the thermal camera and instead plug this USB-C cable into my phone, you'll see something a bit different. So put my phone in there, and you'll see the tester is now powering up. And if you're looking closer at that USB tester, you can see it's outputting 5 volts, 0 amps. I think the phone's fully charged or something, but yep, that is now actually powered up the USB port, and it is outputting power to my phone. This wasn't happening with the camera, so again, if you unplug the phone, plug the thermal camera in again, no power is being put out. However, if instead of using this USB-C to USB-C cable, we plug this USB-C to A adapter in, and then use a USB A to C cable, this adapter contains the appropriate resistor values to essentially tell a USB-C port to output just 5 volts. So if we plug that in there, the second we plug that in, the meter starts up and shows it's outputting 5 volts. And then when we plug the camera in, you'll see it starts drawing current and the camera will power up. So it's a little bit annoying. Essentially all it means is you can't use a USB-C to USB-C cable with this camera. Obviously a USB-A to C cable works perfectly fine, and if you're wanting to use it with a USB-C laptop like this one, all you would really need to do, I found the best workaround, is just to get a cheap USB-C to USB-A adapter like this, stick it on the end of a A to C cable, and just keep this cable as the cable that's used to connect this camera to a USB-C device. So all I'll do is I'll just keep this cable, I'll put it in the carrying case with the device, and I'll just keep it alongside the device at all times. And this will just be the cable I'll use to connect to USB-C devices. It is just a little bit annoying. I actually spoke to HIKMICRO about this just to see if they were aware of the issue and what they were saying about it. They are aware of the issue. Unfortunately, as I suspected, it's not something that can be fixed in a firmware update. It is a hardware thing that we need to be changed. They are apparently going to be working on future hardware revisions of this that will fix this problem. So it may be a case that a few years down the line, this isn't an issue anymore, and newer Pocket 2s work perfectly fine. But currently it is an issue. So if you want to use this with a USB-C device, you need to have a cable like this, which is with like a USB-A to C adapter in it. You can't use it with a USB-C to USB-C cable, which is a little bit annoying, but it does work. Hopefully they fix it in future revisions. It's just, that was a lot of confusion trying to work out what the problem was here. But at any rate, this is a Mac and the software is Windows only, so we'll get the Windows machine in and use a USB-A to C cable to connect up to this. But I just wanted to demonstrate that in case you've got a more modern machine that has a USB-C port, you need to have a bit of a cable bodge to make it work. Okay, so here we have a Windows laptop we'll actually be testing it with a USB-A to C cable connected into it. And this is where there's one more weird issue I found with the USB port. And that is if we plug it in there, give it a second, you can see on the laptop here we've got a message saying power surge on USB port, which is a bit weird. Now, I don't know how much of this is due to the Pocket 2 versus this laptop. This laptop is ancient and it is properly dying on me. Like it's crashing and getting really unstable. The other day the screen randomly faded out to static. There's something really wrong with it. But if we plug the USB meter in again and then plug the camera into this, you can see that the camera with quite low battery level is drawing 1.7 amps. And I tested this in a wall charger and it was drawing like 2 amps. So I think what's happening is it's drawing too much current for this laptop's USB port and it's causing the laptop to throw up this warning. Now again, I don't know if it's this laptop, it very much could be. And what I have found is that it depends on the battery level of the Pocket 2. If the camera is charged up nice and full, it's not an issue at all. It draws basically no current and it works perfectly fine. However, if the camera battery is a bit low, so this is currently about 50%, I've deliberately drained it for this demonstration, it draws a lot more current trying to charge up, and that's upsetting this laptop. So of course, that may just be down to this laptop and other devices might be fine. However, I've also tried it with this USB-C type dongle that I use with my MacBook Pro, and I found that this was also a bit unhappy when this has a relatively low battery charge. If you plug it into here, it's got like a little light that comes on to indicate that it's got power. And this light would just blink on and off as though this contains some sort of power limiting circuitry as well. And this was also tripping out when this was being charged from it. So yeah, if you find that's an issue, again, you can easily enough work around it. But what you just need to do is make sure this is reasonably charged up. So if you're finding that it is drawing too much current and your computer is complaining or whatever, just charge this from a USB wall power supply, get it nice and fully charged. By that point, it'll only be drawing like 0.6 amps. And at that point, it's perfectly happy to be plugged directly into a laptop. So yeah, USB port's a bit quirky in the sense that it doesn't work with USB-C to USB-C cables, and when it's charging up, it draws quite a lot of current, which might upset some computers. But realistically, you can still get around it. It just means that rather than using a C to C cable, you need to use a C to A cable, and if you want to connect it to a USB-C port, put an adapter on the USB-A end. And if you find that it draws too much current when charging to power it from your particular computer, charge this up off of a wall power supply until it's nice and full, and at that point it works fine. So hopefully it's the sort of thing that will fix in a future hardware revision, but I did want to mention it because it did confuse me quite a bit when this was doing this and I couldn't quite work out what was wrong. But anyway, now we've got a solution. Let's plug it into the computer and take a look at the Windows software. So now here we are on the computer, and I've connected the camera to it, and as you can see, it just shows up as a USB device. So it just shows up as a USB storage device. You don't need to worry about any drivers, and even though the analyzer software, it's called HIKMICRO Analyzer, is Windows only, there's nothing stopping you connecting this to a Mac or a Linux machine and pulling your images off of it. It just shows up basically like a camera. Go in here, there's all your folders, there's all your images, and they're just standard JPEGs you can open up. However, as I've alluded to, there's the HIKMICRO Analyzer software that is so useful. So instead of just browsing these images, we'll come over to it here. It's free software, you can download it from HIKMICRO's website. Come over here, go to local file, already browsed the directory, and here's all the images off of the camera. So we pick one of these ones, say we'll pick this one of the inside the laptop, right click it and press Analyze. It pulls the image up full size. But what we can now do is very easily dig into this. So first of all, you can see this is a fusion image. However, if you look over here, we also have the real camera image embedded alongside the thermal image. It's not just a standard image. So what you can actually do is, after the fact, you can come in and change that from a fusion image to just a thermal image, or a blending image, or picture-in-picture, or visual. You can actually change the capture style after the fact. Now, this is one thing I'll say as a slight privacy issue, not in a real, it's not a bad thing. It's just something to be very mindful of if you are using this device. And I don't really know how they've done it, because they've done some crazy file format magic here. But if we look in here at the images, all there is in here is standard JPEG files. There are these thumbnail files, but these are thumbnails for the videos. These are just standard JPEGs. So if we find the image in here that's the one ending in 949, which is this one, if you look at that, it just shows up as a normal Fusion JPEG. That's it. But somehow encoded in that file, even though it shows up as a normal JPEG in standard image editing software, it is actually encoding the image from the visible light camera and the thermal image separately. Now this is super useful, and we'll take a look at that in a second. But I think it's just worth bearing in mind that if you were using this camera in, say, a sensitive setting, say a commercial office or data center or something like that, where taking photos would maybe be an issue for privacy, when you're taking thermal images, you are also actually capturing into that same file an image from the visible light camera. And if you compare these two, you can see the image from the visible light camera has a much wider field of view than the thermal image. So it's just worth bearing in mind that, say if you're doing a thermal performance survey of an office, you would want to be careful, because what you could quite easily do is take a thermal picture of the office, get a fusion image like this, and send that JPEG to someone. However, what that file would actually contain would also be this visible light camera image with a wider field of view. So for example, there could be a monitor in that office with sensitive data on it that's out of the field of view of the thermal image, so when you look at the JPEG through your normal image viewer software, you don't see it. But if you were then to send that file to someone and they were able to analyze it in the software or whatever and open up the image, they could actually see a wider field of view which may contain that monitor or document that contains something sensitive. So I thought I would just do an example of this just to explain it better. So here we have a JPEG image that I've taken off the camera, and as you can see here, all it is showing a speaker, a TV and a printer, so it's off to the side of my desk. And this hotspot here is the edge of my monitor, but you see the monitor itself isn't in the image. So if you were just to send that JPEG to someone, you look at this and go, yeah, there's nothing in that sensitive, I can easily send this on to someone. But if you open the same file in the HIKMICRO Analyzer software, so you see it's on the desktop, it's the same file, the camera's not connected right now. You can see here there's no D drive, the camera's not connected, so this is the only file on this computer from that thermal camera at all. But if we open this, or right click it and go to Analyze anyway, and if you look over here, you can see the edge of the monitor with some text on it that says top secret. Now, of course, that isn't exactly top secret information, but if you imagine this was like an office and that was some confidential information on the side of a screen, you could easily, you were, say, trying to just cut out the image, so you tried to move the camera so it was just out the edge of the image, and then you took your image. That JPEG file actually could contain a bit of that image from that screen that you weren't expecting. Of course, it's quite small over here, but you can get it bigger if you go to if you just show the visual image here, it doesn't show what's on the screen. It doesn't show the full aspect ratio, but if you go into Fusion, adjust Fusion alignment, you can then adjust all that, then hit OK, and that's now brought that image from out the side of the picture into the main frame. And you can see, for example, go here, change that to visual, and now there you go. You've been able to extract that extra information that was cropped out of the thermal image in the sort of JPEG view that you see when you open it in an image editor. So yeah, not the end of the world, really not a big deal, and I also wouldn't even call this a flaw. It's just behavior of this device that you need to be aware of if you were using it in a sensitive environment. But really, as long as you're mindful of that, it's not a problem at all. However, this actually makes it super useful because obviously I've mentioned you can change the fusion and thermal and change how it's presented, but you can also adjust the alignment of the fusion image. So even if you don't get it perfectly right on the camera by setting the distance, you can easily come in here, nudge it around anyway, and get that so it's perfectly lined up. So if we do that there, and just tweak it around, and you get a much better alignment. So that is extremely useful. What you can also do is adjust the thermal range. So obviously I mentioned you're capturing a certain thermal range. You can actually come in here and kind of adjust it. It's probably not as good as actually doing it on the camera at capture time, but it does allow you to kind of come in, adjust this, kind of adjust the contrast, and get it looking a bit more accurate. So you can get it kind of looking how you want it, which is really useful if you're generating reports. You can also come in here obviously and you can change the color scheme as well, so which is super useful. But I think the even cooler, more useful thing is obviously, as I mentioned, or as you saw on the camera, it gives you this minimum maximum temperature and the center temperature, and it also highlights these points on the screen here that it's referencing. However, if you look at me moving the mouse around, you can actually see it shows a live temperature of the point that I'm hovering the mouse over. So you can easily take a thermal image, come in on the computer after the fact, and actually see the data. For example, if I'm looking at this here, I want to know how hot the storage controller is, I can actually come down here, hover over it, and actually read that value, which is so cool. I was not expecting it to do this. You can also do things like you can put overlays on to kind of highlight stuff. If you put an overlay like that on, it highlights the hottest and coldest point within that box, labeled R1, the box labeled R1, so you've got a hot point and a cold point, which then puts up in the corner here. You can take points, you can put additional points all over it, so you can put P1 there, put another one down there, like that. So let's put these additional points on, which then also adds to the list of temperatures here. So you can come in here and actually mark up your image by adding in all these areas and points and all this kind of stuff and get all the temperatures. Then with these points in place, you can come over here to these measurements, which shows all the different points that I've put in. But then if you pick one that's not just an individual point, that's actually like a range, you can see here if we pick the image, it shows a histogram of all the points. And if I click on say R1, which is this box I put in, we can see a histogram of all the different temperature readings over that in that small area. So that's also really neat. And of course, what you could then do is you could just export this as an image, but what you can also do is generate a report. So you can go to report up here, pick from all these different templates. We can say, right, I want the diagnostic report with the, or I want the diagnostic report which has the thermal image next to the real camera image. Click that, click OK, and that will generate a report. So you can come into here, it's got all this sort of information here, overview page there. There's your images, shows all the points that I've put on it, shows the temperatures at each of those points, shows the real camera image cropped into sort of the same aspect ratio. Obviously, if you look on the cover page, it's got this information here where it shows like client address that's nonsense I typed in. But you can actually come up to here, click text property, and actually fill all these details in. So client, test client, address, put an address in here, 123 Street. Okay. And that actually fills all this in. So you can actually build a report in this. And then you can export the report, and you can either export it as a PDF, which you can just open it as a PDF, or you can export it as an ODT file, which is like a Word open document file, which I could then open here, open that up, and it'll actually open in Microsoft Word and let me edit that as if it's a Word document. So you could actually use this to very easily generate these reports, open it up in Word, finish off adding all the information in, and export it as a PDF for your client. So this is super useful. So as you can see here, this is just so powerful. Obviously this is dark mode, but I can easily come in here, I can edit this report and then output that as a PDF. A particular example of another one I did previously, there's a report here, open it up, there's a PDF, and you've got a nice PDF file that you can easily send to someone with all your thermal information in it. So yeah, being able to generate things like reports from this software is really flexible, and especially being able to come in after the fact and add those points of different temperature readings in is super useful, and I wasn't expecting it to have this level of flexibility. So yeah, having this super powerful Windows software is super useful, and it's a massive selling point of this particular camera. So there you go. That was a look at the HIKMICRO Pocket 2 thermal imaging camera. And as I keep mentioning, I'm very happy with it. I'm so impressed with the power of this, especially that Windows software, being able to go in, adjust all the images after the fact, get different readings at different points, produce reports. I wasn't expecting that level of power. And then with it being an all-in-one device and having the visible light camera, it makes those fusion images so good. And it is so much better than a purely thermal camera, especially if you're sending those images to people or putting them in reports. Having that visible light section that just makes the image so much clearer and easier to understand. The macro lens is also very useful. It's not the sort of thing that's worth buying if you're just doing it for using this for building performance surveys, but if you're ever dealing with really small electronic components, this is really useful. The only real issue is that quirk with the USB port, but as you can see, all I've done here is I've got a USB-A to USB-C cable I keep in the case, and I've just put the USB-C to USB-A adapter on one end, so that just stays in the case there. And if I'm ever connecting this to a computer with a USB-C port, I just make sure to use that cable. And because it's kept in the case with the camera, I'm never going to lose it. So yeah, hopefully you found this video interesting. If you wanted to buy one of these, I've put a link in the description and in a pinned comment. But after that, all that's left to say is, thank you very much for watching.